Hey everyone, welcome to another Tutorial Tuesday. So in this one, I want to talk about exceptions. And I specifically want to talk about exceptions in C++, right? So we're not talking about things like Python or C# or any of that stuff. But in C++, now if there's one thing that we're sort of taught is that exceptions are bad, right? These are bad. Don't use these. But why? That's kind of my sort of retort to this is, why are they bad? And I can spout off all the things that you could easily Google and all of that kind of stuff, but what fun is that, right? Let's actually look into this. It's common even today to turn off all exceptions. And, like me, I do it automatically. I actually was curious about this not too long ago because, it's been proven to me that they're bad, but also it was proven to me that they're bad in the early 2000s. And I'm like, well, okay, it's 2019, So are they okay now? Is this just a thing that we can do? So what I want to do is I want to do a little performance test. And so let's talk about what this is going to look like. So I think there's 3 states that we want to look at. One thing is I think we can hopefully all agree on is exceptions mean something catastrophic happened, something bad happened, and we want to recover. So we don't want to use it for game logic ever. Even the C++ standard says never use this for real, actual logic. So we're not even going to bother with that. I'm not even going to test that side of it, although we'll see why it's bad just by virtue of some of the tests that we're doing. So the first test is going to be it's going to be your full kind of stack of try catch. That's our first one. Our second one, which I think is going to be probably more real, is try, but we never catch. In other words, in fact, I'm not even going to say catch. There's a better way, I think, to say this. I'm going to say try and throw. So in other words, within this try, we are going to throw an exception. We're going to throw several. Whereas within this try, we're not going to throw. So it's not about catching, it's about throwing. We're not going to throw any exceptions. We're just going to try over and over and over, but we'll never actually throw the exception. And then 3, just as sort of a baseline for fun, we'll do a full no except. Now, I think that this guy right here, this is probably the typical use case, right? I think that probably certainly amortized, you're never going to actually hopefully throw an exception. If you've thrown an exception, something very bad happened. So I think this is the typical use case. So if this is okay, maybe it's okay to use exceptions. But let's find out. Let's actually see what's happening. So I've just created this thing. Literally, it's just a random number generator, and you'll see why. So I've seeded this just with time, and that's fine. I actually maybe want to seed this slightly differently. But for now, oops, not void. I'm just going to do a thing, commonly if you need to generate some index, the 2 ways to do it is you can return a bad index if this thing returns failure, is you can have this return a signed integer of some kind. You can have it return -1, or another common thing to do is, some kind of numeric limit for size t max. This is pretty common too. But those are all kind of lame. So, let's do it the more so in something like Python or C#, probably what you'd end up doing is you throw an exception in this case. You got a bad index, bad stuff is happening. So I'm going to do this. I'm going to say size t index equals grng dot ran64. And we'll just do, 0 to 99 basically. And then we can't guarantee exactly what this is. So we'll just sort of force it to be the thing that we want, like that. Cool. Okay. So this is our index. So now I'm going to do my little exception. And I do so little that I actually have to look all this stuff up, right? And there's a catch here as well. So this try is going to say if index is less than 50, then we're going to throw an exception. And to be honest, I always have to look this up, right? I almost never do this, but here we go. If you're curious, standard exception, these are the sort of general exceptions that exist. Like you can sort of inherit from these. You can create your own, obviously. But these are kind of the major ones, the core interfaces. And in general, you want to inherit from something like standard exception. For pure simplicity, I think I'll just throw range error, which is this guy. So let's go ahead and throw throw a basic range error. So throw, and I need to, if you're going to do this, pretty sure you have to include exception. So here we go. So if I want to throw like a pretty just sort of basic, simple exception, then the easiest way to just hit this throw is to just throw kind of the exception itself. So we're going to say, what did I say? It was range error. Yeah, range error. So standard range error. And it has, this constructor. Like, what are we going to do? I'm going to pass in some message, range error, whatever we want to say. So we're going to throw this guy. Else, we're going to happily return the index. So in this instance, we are throwing 50% of the time, approximately, right? However many times I call this, we're going to throw approximately 50% of the time. And that's essentially what I'm looking for. So now with this catch, we can do standard exception, right? That's not what I want, standard exception or whatever, but that's generally considered poor form. So I'm going to specifically catch my range error, X or something like that. And then here's my actual catch. Oh no, why'd you do that? That's never the right thing to do. And then down here, we'll say C out. We'll just print it out, right? X dot, I think, here it is, what? So I think that's it. So, we'll just print it out. It doesn't matter. And then down here, of course, we'll return index. I'm actually going to do this a little differently, but let's say size t, let's do this. For size t I equals 0, I is less than, let's just create some value. Let's do const expression size t. What's a good number? I like to use, 1,000,000. Seems like a reasonable number. It might help if I gave it a name. Numtest equals this. Great. So numtest, right? Plus I. Cool. So I think I'm actually going to do it this way. So instead of putting the try catch here, which is sort of wonky, I'm going to put it out here. This seems more useful to me. So I'm going to say try, and then we're going to try our get index. So I'm going to, this is going to be tricky to do without having this thing optimize it away from me. So why don't we store these in some vector? Whenever I have to teach optimization, I think the hardest part of teaching optimization is somehow making it so that the compiler doesn't optimize it out for you. I think that's I'm going to say results, and I'm going to say results.reserve, right? We'll just reserve this, knumtests. And I'm just going to live with the fact that there's going to be some kind of performance issues here, because what I'm going to do is I'm going to say try, let's do it out here. Let's say size t index equals 0, and then here we're going to say try index equals get index. And then we'll do our catch here, which will print this thing out. And then, because this is going to break, and I think I can hit something like continue. Because here, what I'm going to do is I'm going to say something like results.inplaceBack index, something like this, right? So this should work. What I think I don't want to do is I don't want to actually print this out because I don't want to incur the cost of the C out. No, I don't. I hate that it does this. No, that's never the right thing. Okay, so this should do that. Now, the next thing, of course, that I need to do, high precision timer. So I'm going to use this high precision timer. Okay, so this is one test. This is test one, right? So now what I'm going to do here is I'm going to do results.clear. And then down here, we're going to do test 2. So if we go back here, test 1 was try and throw. So now we're going to try and no throw. So the way that I want to do this is I'm going to just create a second get index, basically. Just for fun. Get index, no throw. And I'm literally going to just return the index. Yeah, I'm gonna return the index like this. And then I'm gonna do another version of this where I'm gonna say, instead of no throw, I'm gonna say no accept, and I'm going to literally mark this as no accept, but it's the exact same code. And so this is basically the code. This is what we're gonna check for. So, okay, so number 2, we are gonna do the exact same loop. I wouldn't normally copy and paste this much, but it's just a test, so who cares? I am going to do results.clear down here, so it's obvious what that's doing. Here I'm going to do the try, and I'm going to do the catch and all that stuff, but I would expect this to never throw, right? It's never going to throw. So we'll do that. Okay, and then test 3 is going to be this exact same loop, right? Except in this particular case, there's no try, and there's no catch. Now for these guys, I'm going to do this get index no throw. And then for this one, I'm going to do a get index. I kind of want to do a 4th test. I don't actually know if no accept gives me a performance boost. So I'm going to say no throw, but I'm never actually trying, and then no accept, and I'm also not trying, right? These are going to be my 4 tests. Okay, so now what I want to do, and am I clearing between each one? Yes, I am. I'm doing the results. Good. I mean, I can even do this sort of thing, although it doesn't matter. The compiler is going to optimize this out anyway. But it makes me feel better. There we go. Right. I think this is good. Okay. We're not even going to bother doing this in debug mode, so I've just switched to release mode. Now I need to do my high precision timer. So here's how this is going to work. High precision timer. It just uses standard chrono, for those who like the C++11 chrono stuff. So I'm going to say timer, and then timer dot start timer. And I think do I want to time this whole loop? I think I do. I think I want to time this entire loop. And then down here, I'm going to say double throw test equals timer dot get delta from start. And then we're basically just going to do the same thing, timer dot start timer. And then this is the no throw. So double no throw equals timer dot get delta from start, right? And then we're just going to basically keep doing this kind of thing. So we're going to start a new timer here. Oops, here. And then we'll do another thing here. This one is no try. And then our last one here, we're going to do this guy, which is going to be no accept. Okay. Then down here, we need to actually print this stuff out. So we're going to say standard cout. Oops. Let's do, so we start with our no throw. Oh, it's not no throw. We're going to say try throw. Yeah, the throw test. Okay. So we're going to say throw test. no throw. And then we've got our no try. These results, by the way, it's worth noting, are going to be slightly skewed. I don't think it's going to be massively skewed. I'll certainly know when I see it, because I've done this before. But whenever doing anything with performance testing and running, I'm running OBS here, right? That's going to cause a bit of an issue sometimes. It really depends. I'm hoping it doesn't cause any kind of significant issue. But again, I've run this test before, so I should know. Okay, so we're going to build this. Maybe it'll compile. It won't. I have a couple of things here. What do you want? Unreferenced local variable. Oh, sure. I don't care about that. Normally, I would care about this, but you don't do that. Yeah, normally I would care about this. This is a bunch of weird fallback stuff. Sure. Okay, now double checking, because I think I actually did this at one point. You can turn all this stuff off, right? So hold on, all options. Okay, yeah, I've enabled C++ exceptions. That's useful. Great, so I'm gonna run this. There we go. So these are in milliseconds. If we zoom this guy in, throw test. So where I'm throwing about 50% of the time takes me about a second. Running a million versions of that code takes me about a second. If I'm not throwing, it takes me about 4 milliseconds. If I'm not trying, it takes me 3 milliseconds. No except takes me about 3 milliseconds as well, a little less. And that's my test. So actually throwing an exception and catching it, in my case, I am testing that, is slow. It is several orders of magnitude slower. If I'm never throwing anything, which means I'm just trying, then the cost is relatively small, but there is a cost, right? The cost is, we're looking at it. It's in my case, a millisecond for these million things. Now, hopefully most of what I'm doing, the actual work I'm doing, is going to be like my, loop more than anything else. And the rand call, right, or the call that I'm doing to my random number generator. But even with all of that stuff, I'm getting, it's slower, right? It's a bit, a bit slower. It's, a third again slower. So if I run this again, whoops, I don't want to do that. I don't want to run it through the debugger. I want to run it outside of the debugger. Here's another test. Again, this is kind of anecdotal, but here we go. So now so this is, 1100 milliseconds, right? This is well over a second, 1.12 seconds, 1.13, I guess, seconds. We have about 5 milliseconds for no throw. We have about 3.5 for throwing. So for no trying, for not even using exceptions whatsoever. No except is slightly better. So, I don't know if it's anecdotal here, if it's just how it happens to be done, but no except actually does appear to be slightly more performant. Again, I don't know if that's just luck of the draw or the fact that all this array or whatever's in cache. I mean, there could be any number of things that are very close to each other. Oh, this time it's slightly slower. So I don't know that no except is going to be significant. I don't think it's a significant performance boost. It may be in certain situations, but it's not massive. The no try is I would consider this, while not, orders of magnitude, I would consider never trying, never using the try keyword, to be a relatively reasonable performance boost. It's not massive. And, we're not talking about how deep does this go, or what if I do one big try over my main loop or something. This is literally just what is the cost of just doing this try catch type thing. So yeah, I mean, again, if I'm throwing exceptions with any regularity, this is 50%, 500,000 exceptions or whatever is just undoable in this case. So obviously you can't use it for game logic. So that should prove that right there. Yeah, I would say that no try, no accept are pretty spot on. But these guys, I mean, are consistently 1 to 1.5 milliseconds apart. 1 to 1.5 milliseconds in a game is night and day. I mean, you have 16.5 milliseconds or whatever it is, right? 16.7 milliseconds per frame. So millisecond and a half is massive. Now, this is 1 million objects, but still, like, this is pretty significant. So in general, we turn off exceptions. And this is why. Right? Performance-wise, this is incidentally about what I was seeing, so it doesn't look like VLD is really affecting this at all. Yeah, so you can just see it's pretty consistently, these values. Cool. So that's about it. I mean, this is the closest they've been at slightly less than a millisecond. Okay, so cool. That's it. Hopefully that's some useful information. You can just kind of see like testing, just again, really bare bones test, but it's a test on exceptions and how fast they are, how slow they are, all that kind of stuff. I'm going to continue to turn them off. You saw me do this. I don't actually know exactly what section it's in, but under C++, all options, I literally just search for exceptions. And there it is, enable C++ exceptions. You can literally turn it off. Be aware that if you do turn it off, if I just say no exceptions, and do this, I'm not actually sure what's going to happen with my tries here, but I'm going to give a bunch of warnings. Yeah, here we go. So if I click on this, yeah, it's going to complain that, hey, you have a try here. What are you doing? Amusingly, I'm not seeing it here, but when I do rebuilds with exceptions turned off, certain things, I wonder if unordered map is one of them. There are a few headers that Microsoft has that happily use exceptions whether you like it or not. And so you may just get this warning with a bunch of Microsoft headers because they just use exceptions. Now, one thing that I don't know is what happens, is it okay to just crash? Probably not. I mean, it depends on what the issue is. So that's it. I think next week I'm going to show another alternative for this get index. That might be fun. Okay. Well, thanks for watching, and I'll see you next time.